All right, eighth grade students that I have missed dearly, we are going to finish up the chapter 3, and that is with the extension, which is on page 212. I'm just going to actually go through exactly what the book is going through and explain it in detail. So if you look at example 1, letter A, the problem is the absolute value of x plus 3 is less than 12. Now, you would need to isolate this absolute value of x by first subtracting 3. So now you have the absolute value of x is less than 9. So an absolute value makes everything ways. And you can keep the absolute in at first if it helps you, and then change it in a minute. So either the absolute value of x is less than 9 and or the absolute value of x is greater than negative 9. And it's greater than because when you make something a negative, you flip the inequality. So since the absolute value makes everything positive, we are graphing this and this. So you can remove the absolute values now that you have the positive and the negative. On the number line, you're going to put an open circle at 9 with an arrow left and an open circle at negative 9 with an arrow right. You can go ahead and test to make sure this works. So if you plug 0 in, it works. If you plug something like 10 in, it doesn't work. And if you plug negative 10 in, it doesn't work. So this is your and graph because it doesn't go past the 9s. So that is exactly what your graph should look like. If you want to write the solution then, it would be x is greater than 9 and x is less than 9. I don't really know why I wrote that. So basically this one's here and this one's here. When you have ands, you can write them together. So the negative 9 is the smallest, and then you would have the x, and then the 9. Remember, you're going to read this way. So this, oh, I lost my negative. So this right here is the same as this right here. The Pac-Man is eating the x. The Pac-Man is eating the x. Okay, that's hopefully very clear. Letter B. Absolute value of x minus 7 is less than negative 3. So the first step is going to be to add the 7. So the absolute value of x is less than 4. And then this is broken down into two things. The absolute value of x is less than 4. And then the other thing is flipping the inequality and making the 4 the opposite sign. So let's graph what we're reading here. So at this point, you can remove the absolute value since you have broken it up into both. At 4, you will have an open circle with an arrow left. At negative 4, you will have an open circle with an arrow right because it's greater than. Again, you may want to quickly just test to make sure that 5 doesn't work and 5 is not less than 4, so it doesn't. And you can check with the negative one as well, and it doesn't. So this is the graph, what you're looking at. It stops at both the negative 4 and the 4. So now we know this is an and. So you could write this individually. I'll go ahead and put the negative 1 first since we're going to write it compound. And then you would put the negative 4. The Pac-Man's going to eat the x. What is happening? All right, I do not know what's going on with my marker. And that means and. So the next problem is 2 absolute x is less than or equal to 6. To get the absolute alone, the first step would be to divide by 2. So the absolute is less than or equal to 3. Why don't you go ahead and try and see if you can do this? The first step is to make it the positive and then make it the negative, flipping the inequality. Then you don't need the absolute anymore since you have the positive and the negative. You're going to graph them. This time they have closed circles at 3, closed circle, less than, arrow left. At -3, closed circle, greater than, arrow right. And then you're just going to make sure that 4 doesn't work. 4 is not less than 3, it doesn't. So we are done. This is an and statement, so we can write -3 is less than or equal, not that. 2x, because the Pac-Man is eating the x, so you're really reading it this way, that x is greater than or equal to -3, and then less than or equal to 3. So this right here, you're thinking of as x is greater than or equal to -3, and that's this part, and that's a negative. Letter D on this page is the absolute value of x plus 3 minus 4.5 is less than or equal to 7.5. So your first step is to isolate the absolute value. You would add 4.5 to both sides. The absolute of x plus 3 is less than or equal to 7, 8, 9, 10, 12. Now you're going to write the two equations. This time it's going to take a little solving. So the absolute of x plus 3 is less than or equal to 12. And then you're also going to write the absolute of x plus 3 is greater than or equal to -12. Now you can get rid of the absolutes and solve. So x plus 3 is less than or equal to 12. And x plus 3 is greater than or equal to -12. Oh my goodness. So subtract 3. If you can read this, x is less than or equal to 9. And then over here you're going to subtract 3. X is greater than or equal to -15. So on a number line, you are going to 9. Closed circle, arrow left, and then you're going to go to -15, closed circle, arrow right. Most likely they're going to connect. That seems to be the theme. Go ahead and test 10. Is 10 less than 9? No. And then go ahead and test -16. Is -16 greater than -15? No. Remember, and means it works for both. So when you've found one that it doesn't work for, you know that you're done and that what you have graphed here is your answer. This is an and. So we can go ahead and write the compound inequality. So -15, and then you're going to put is less than or equal to x, because again, this is red. X is greater than or equal to -15, and that's what is graphed right here. And then over here, you're going to put less than or equal to 9. And that's what this is, less than or equal to 9. And that's where they connect. So all of those were ands. Now we're going to go to the ors, and then I'll give you a couple problems. So if you want to flip the page, if you're following on the paper, we're now on page 214, if by chance you could read that. So the first one on this is absolute value of x plus 5 is greater than 14. The first step would be to add 5 because you're going to isolate the absolute value. And then you're going to put both of your situations. So the absolute value is greater than 19. It's also less than -19. Then you can lose the absolute value. X is greater than 19. X is less than -19. And then you can plot it. At 19, you have an open circle. It's greater than, so arrow right. At -19, you have an open circle. It's less than, so arrow left. So this is an or. Ors, you don't write as a compound inequality. You just leave them separate because they don't come together. So you can just write the negative one first if you would like. X is less than negative 9, or X is greater than 9. It's always a good idea to test yourself and just make sure by plugging in an answer. So, can I go back up? Okay, stop. So to test, if you want to plug in 0, 0 shouldn't work for either. So is 0 greater than 19? No. So that checks out. Is 0 less than negative 19? Nope. So that checks out. So you should be feeling like, yep, I did that right. I am feeling super happy. Letter B reads, absolute of x minus 20 is greater than negative 13. The first step, isolate the x. So you're going to add 20. So absolute of x is greater than 7. Now you're going to write this twice, one with the positive. I'm going to make my 7 with a line through it. And one with the negative, flipping the inequality. Now you don't need the absolute value because the absolute value is completely isolated. That needs a negative because you made it negative and that's why it flipped. And then you're going to plot both of these. So at 7, you have an open circle with an arrow right. At negative 7, you have a closed open circle with an arrow left. This is an or, so this is your answer. X is less than negative 7, or X is greater than 7. You can't put it together when it's an or, and then you might want to just test really quick. If you plug 0 in, it does not work. It does not work, so you definitely did that right. Hooray! Okay, I'm going to give you one to try. X minus 8. Oh my gosh. Oh my goodness. Absolute of x minus 8 plus 5 is greater than or equal to 11. So go ahead and hit pause and see if you get the same answer I get. All right, your first step should have been to subtract 5. So absolute of x minus 8 is greater than or equal to 6. I'm really sorry about the board, all of you lovely people. I don't even know what to do. You're going to now make this both the positive and the negative. So when you make it the negative, you're going to flip the inequality and you're going to make the second answer the opposite. And then you're going to get rid of the absolute value. Because it's isolated, there's nothing else that can be taken away, so the absolute's alone. And then you're going to get the letter alone, so you're going to add 8. So x is greater than or equal to 14. And when you add 8 here, you get x is less than or equal to 2. And then you graph. So at 14, you have a closed circle with an arrow right. At 2, you have a closed circle with an arrow left. This time if you plug 0 in, it'll work, so you don't want to plug 0 in. You can plug anything in between. 10 might be a good one to plug in. And when you plug it into both, it doesn't work, so you know you did it right. So you can write this as x is less than or equal to 2. Usually the smaller one goes first. Or x is greater than or equal to 14. All right, I'm going to give you 2 more to try. So the first one is going to be the absolute value of 3x plus 2 is less than 8. And the second one is going to be, I'll put it farther down. the absolute of x, I'll just do this one, is greater than 16. All right, go ahead and try those, and when you're done, unpause. So in the first one, your first step should have been to subtract 2. So the absolute of 3x is less than 6. At this point, you're going to write both the positive and the negative. And then you're going to get rid of the absolute. I could have had the absolute there, just kind of saving a step. And then you're going to get the x alone. This time it's through division. So x is less than 2. And x is greater than negative 2. So on your number line, at 2, you have an open circle. X is less than, so it's an arrow left. And at negative 2, you have an open circle. X is greater than, so an arrow right. So I'm thinking it's an and since they're converging together. I'm just going to plug in 3 to the positive one and make sure it doesn't work. So that's this one right here. So 9 is not greater than 6. It's actually this one right here. And then I'm going to plug in the negative 2 right here. 3 times negative 2, or like a negative 1, 3. So 3 times negative 3 is negative 9, and negative 9 is not greater than 6. So you're plugging in something like 1 here, testing that it doesn't work, and you're plugging in negative 3 here, testing that it doesn't work. So we know for certain the outer ones don't work, so they converge together and stop. So this is an and. So you could either write them as a compound inequality, which means they're all together. So negative 2, this reads x is greater than, so the Pac-Man is eating the x, and then this one reads x is less than. And that's your compound inequality. That is your and. In the second one, you should have added 6 first. And then you can take the absolute value with you, or you can just put x is greater than 22 and then also put x is less than negative 22. Remember, you're changing the sign and flipping the inequality. On a number line at 22, you're going to have an open circle. X is greater than, so the arrow is right. At negative 22, you're going to have an open circle. X is less than, so the arrow's left. This is a good time to test 0 just to make sure you did things right. 0 shouldn't work for either. 0 is not more than 22. 0 is not less than negative 22, so this is looking good. This is an or. It goes in opposite directions. So I'm going to put the negative solution first, and then I'm going to write the word or, and then I'm going to put the positive solution second. Now, the only last little tidbit I'd like to look at is on page 215, the ones where you're given the graph. So if you look at 16, you have a number line, and at negative 2 and at positive 2, there are closed circles, and it looks like this. So this you could write as a compound inequality. Negative 2 is less than x, or whatever letter you want, is less than 2. And when you have the compound inequality, that stems from the initial problem of the absolute value of x being less than 2. This part of the problem comes from taking this and making it the positive and the negative. So this is the same as this. So your actual answer is that this is the problem that gave you that as your inequality. So I'm going to give you one to try, see if any of that works. So if you look at 17 on that page, you are at 3 and negative 3, and you're going in opposite directions this time. So go ahead and see if you can write that in an absolute form. So already you're thinking this is x is less than negative 3, or x is greater than 3. And when you have the ors, your absolute value is oftentimes greater than, and that's what makes this, when you break it up, this, and then that's what makes this, when you break this up into the opposite, that. So a lot of times if your absolute is pointing, you will have an or situation. Not 100% of the time, so always test to make sure. So I'm going to give you one more. We're jumping down to 19. We're at 7 and negative 7 coming together with an open circle. See if you can write that equation. I just realized one little thing. In 16, that closed circle, this should have been an equal to because it's a closed circle. So open circles don't have the equal to, closed circles do. Hope I didn't disturb any of you. Okay, so this is an and, so you can write that compound inequality. And then you're just sort of looking at this part because the other part stems from the opposite, and it's the absolute value of x is less than 7. That's your answer. If you want to test and make sure you did it right, you can keep going and say, okay, if that was the initial problem, you would have x is greater than 7, which you have, and then you would have x is greater than negative 7. Hopefully I said less than when I read that, which you have because you're reading it this way. So that is your answer. Well, hopefully you enjoyed this discombobulated board that's writing all over, and absolute values making a little more sense with the words and or. Have a lovely evening.